the metallic smell of space. First documented during Gemini and Apollo missions, astronauts consistently reported a distinctive metallic odor clinging to their spacesuits after extravehicular activities, despite space being a vacuum incapable of transmitting scent. The smell registers as sweet metallic, similar to burning metal or arc welding fumes. It appears immediately when repressurizing airlocks. This phenomenon results from atomic oxygen in low Earth orbit bonding to spacesuit materials during vacuum exposure, then oxidizing rapidly when reintroduced to breathable atmosphere, creating volatile organic compounds that trigger olfactory receptors. Every astronaut performing spacewalks experiences this sensory anomaly. It serves as tangible reminder that their suits have been chemically altered by the void. The smell persists for hours, permeating spacecraft interiors. No Earth-based environment produces this exact combination of chemical signatures, making it uniquely extraterrestrial. This olfactory ghost of vacuum exposure reveals that space touches everything it contacts, leaving molecular fingerprints that follow astronauts back inside. Next up, micrometeoroid impact frequency. Operating beyond Earth's protective atmosphere, spacecraft and suited astronauts face continuous bombardment from micrometeoroids traveling at velocities between 10 and 70 kilometers per second. These particles range from dust grain size to pebble diameter. They strike with kinetic energy equivalent to bullets despite their microscopic mass. The hypervelocity impact physics involves complete vaporization of both projectile and impact site, creating plasma explosions that crater aluminum surfaces and puncture thin materials. International Space Station windows require regular replacement due to impact damage. Typical service windows display hundreds of microscopic craters after months in orbit. At 40,000 impacts per day documented on ISS surfaces, the statistical danger becomes probability calculation rather than possibility. A 3 mm particle striking an astronaut's helmet visor possesses sufficient energy to penetrate polycarbonate layers designed to withstand such impacts. Space operates as endless firing range where the ammunition never stops, and every surface becomes target scarred by cosmic erosion, travelling faster than rifle rounds. Moving on. Solar radiation storm intensity. Beyond Earth's magnetosphere protection, astronauts travelling to the Moon encountered solar particle events that delivered radiation doses hundreds of times higher than terrestrial background levels within hours. These storms erupt from solar flares and coronal mass ejections, accelerating protons to relativistic speeds that penetrate spacecraft hulls and human tissue. The ionizing radiation damages DNA directly, creating double-strand breaks that trigger cellular mutation or death, while also producing secondary radiation through nuclear interactions with spacecraft materials. Apollo astronauts reported seeing bright flashes even with eyes closed during lunar missions, caused by high-energy particles traversing their optic nerves and creating Cherenkov radiation in vitreous fluid. A major solar particle event during unprotected lunar surface activity would deliver a potentially lethal dose within hours. No natural shelter is available. Current radiation shielding technology adds mass penalties that make adequate protection for Mars missions prohibitively expensive. The Sun periodically transforms from life-giving star into scattershot weapon, firing invisible particles that rewrite the genetic code of anything unshielded in their path. Next we have the profound silence of orbital space. First experienced during Gemini extravehicular activities, astronauts describe the absolute silence of vacuum as psychologically disorienting beyond any earthly quiet environment. Sound requires molecular medium for propagation. The near-perfect vacuum of orbital space contains insufficient atmospheric density to transmit mechanical waves detectable by human hearing. This sensory deprivation removes evolutionary warning systems developed across millions of years, as approaching dangers produce no auditory signature. Astronauts report that equipment failures, thruster firings, and impacts occur without sound, creating disconnection between visual events and expected acoustic feedback. The silence registers as oppressive presence rather than mere absence. Some astronauts describe it as feeling entombed despite the infinite openness visible through helmet visors. Communication depends entirely on radio systems, making equipment failure potentially fatal isolation. This acoustic void demonstrates that space actively removes sensory capabilities humans depend upon. leaving astronauts functionally deafened in an environment where hearing once meant survival advantage. Up next, cosmic ray visual phenomena. Deep space astronauts, particularly Apollo crews traveling beyond Earth's magnetosphere, consistently reported seeing random light flashes occurring several times per minute, even in complete darkness with eyes closed. These phosphins result from high-energy cosmic ray particles traversing the retina and optic nerve, depositing sufficient energy to trigger false visual signals that the brain interprets as light. The phenomenon intensifies during solar minimum, when galactic cosmic radiation peaks. Some astronauts documented flash frequencies exceeding 2 per minute during translunar coast. Each visible flash represents a particle capable of damaging cellular DNA, making the light show a visual dosimeter of accumulating radiation exposure. The flashes appear as streaks, dots, or starbursts, depending on particle trajectory through ocular tissue. Unlike Earth, where cosmic rays are filtered by atmosphere and magnetosphere, deep space astronauts see their radiation exposure in real time. These phantom lights transform invisible danger into persistent reminder that high-energy particles are continuously passing through brain tissue, eyes, and every organ, with each flash serving as a receipt for potential cellular damage. Next up, spacecraft outgassing and material degradation. Materials carefully selected for spacecraft construction unexpectedly release volatile compounds when exposed to vacuum, creating hazardous atmosphere contamination that threatens crew health and equipment function. Plastics, adhesives, lubricants, and sealants outgaze molecular constituents that accumulate in closed cabin environments, producing toxic concentrations of formaldehyde, benzene, and other organic compounds. The vacuum environment accelerates this molecular escape by removing atmospheric pressure that normally contains volatile substances within solid matrices. Astronauts aboard Mir reported eye irritation and respiratory issues traced to degrading insulation materials releasing formaldehyde at levels exceeding safety thresholds. Additionally, ultraviolet radiation and atomic oxygen exposure degrade external materials, making components brittle and discolored within months. Equipment designed to last years on Earth fails within weeks when vacuum, radiation, and thermal cycling attack molecular bonds simultaneously. Each material brought to space becomes potential contamination source, slowly decomposing into atmosphere that astronauts must breathe. Space does not merely surround spacecraft, but actively disassembles them at molecular level, turning protective barriers into sources of the poisons they were meant to exclude. Moving on. Bone density loss, acceleration. Microgravity environments trigger skeletal demineralization at rates 10 times faster than osteoporosis, with astronauts losing 1 to 2% of bone mass monthly in areas bearing no mechanical load. The absence of gravitational stress removes the mechanical stimulus that signals osteoblasts to maintain bone density, while simultaneously accelerating osteoclast activity that breaks down existing bone tissue. This calcium loss concentrates in urine, creating kidney stone risk while weakening structural integrity of weight-bearing bones. 6-month ESS missions result in bone density reductions equivalent to decades of aging, concentrated in hips, spine, and femurs. Exercise countermeasures using resistance equipment partially mitigate but cannot fully prevent this deterioration. Astronauts returning from extended spaceflight face increased fracture risk for years after landing. Some bone loss proves permanent despite aggressive rehabilitation. The skeletal system, evolved under Earth's gravity across hundreds of millions of years, begins cannibalizing itself within days of reaching orbit. Removing gravity does not free humans from Earth's influence, but instead reveals how fundamentally our biology depends on the constant downward pull that shapes every bone from birth. Next, we have the overview affects psychological intensity. Viewing Earth as complete sphere suspended in void produces profound psychological transformation, documented by majority of astronauts, manifesting as sudden emotional overwhelm and permanent worldview alteration. This cognitive shift occurs when the brain processes the visual reality of Earth's isolation, fragility, and the absence of visible political boundaries that dominate terrestrial thinking. Astronauts report tears, existential awe, and instant recontextualization of human concerns when seeing atmosphere as thin blue line and continents as unified landmass. The emotional intensity often arrives unexpectedly during routine operations. It is described as more powerful than any earthly experience. This perspective permanently alters perception of environmental issues, political conflicts, and human significance. Many astronauts report that their entire value system restructured around the visual fact of planetary unity. No photograph fully captures the experience because the human visual field's peripheral awareness of endless void surrounding Earth creates visceral understanding unavailable through images. The psyche evolved in environments where horizons measure kilometers, faces sudden expansion to planetary scale, triggering response patterns for which evolution provided no preparation. Space reveals Earth not as stable foundation, but as isolated island of life, whose atmospheric shield appears terrifyingly thin when viewed edge-on against the infinite darkness beyond. Up next, temperature extremes and thermal cycling severity. Objects in low Earth orbit experience temperature swings of approximately 280 degrees Celsius every 90 minutes as they transition between direct solar exposure and Earth's shadow. Sunlit surfaces reach 121 degrees Celsius. Shadowed areas plummet to minus 157 degrees Celsius. This creates thermal stress that fractures materials through repeated expansion and contraction. Cycling occurs 16 times daily, subjecting spacecraft components to thermal fatigue equivalent to years of Earth-based operation within weeks. Spacesuits must regulate internal temperature while their outer layers simultaneously face welding torch heat on sun-facing surfaces and cryogenic cold on shadow sides. Unprotected human skin would alternate between severe burns and frostbite within minutes of this exposure. The thermal extremes result from absence of atmospheric convection and conduction, leaving only radiation as heat transfer mechanism in vacuum. Metal components expand and contract by millimeters with each orbit, requiring careful engineering of joints and seals to accommodate this constant dimensional change. Space imposes temperature regime that no earthly environment matches, where surfaces experience the heat of boiling water and the cold of liquid nitrogen within the time it takes to watch a television program. Next up, fluid redistribution and facial swelling. Microgravity eliminates hydrostatic pressure gradients that normally pool fluids in lower extremities, causing approximately 2 liters of blood and lymphatic fluid to shift toward the head and upper body within hours of reaching orbit. This redistribution produces characteristic puffy face and bird leg appearance in all astronauts, accompanied by sinus congestion, headaches, and increased intracranial pressure. The cardiovascular system interprets this cranial fluid accumulation as volume overload, triggering compensatory response that reduces total blood volume by approximately 15% through increased urination. Vision degradation affects majority of astronauts on long-duration missions, caused by elevated intracranial pressure flattening the posterior eye globe and creating hyperopic shifts requiring corrective lenses. Some astronauts experience permanent vision changes even after returning to Earth. The lymphatic system, which relies on gravity and muscle movement for drainage, becomes sluggish, allowing metabolic waste to accumulate in tissues. Evolution designed the human circulatory system for constant 1G environment, making the heart and vascular network actively malfunction when gravity disappears. What feels like floating freedom is actually cardiovascular confusion. As the body floods the brain with fluid it thinks needs draining from legs that no longer exist in gravitational sense. Moving on, ammonia leak toxicity threat. International Space Station cooling systems circulate anhydrous ammonia, a compound so toxic that exposure to 400 parts per million proves lethal within 30 minutes. During documented ammonia leak events, astronauts face potential cabin contamination, requiring emergency evacuation to alternate modules and donning protective equipment within seconds of alarm activation. Ammonia's high toxicity results from its rapid reaction with water in mucous membranes, creating caustic ammonium hydroxide that destroys respiratory tissue and causes pulmonary edema. The compound's pungent odor provides warning at low concentrations, but olfactory fatigue can occur, reducing detection capability during sustained exposure. Leak scenarios require immediate isolation of affected modules, potential emergency spacewalk repairs, and consideration of station abandonment if contamination becomes widespread. The necessity of ammonia stems from its superior thermal properties for rejecting waste heat in vacuum, Honda making an engineering choice that introduces severe toxicity risk into closed environment. Each day aboard ISS means sleeping meters away from pressurized tanks containing substance that could kill the entire crew faster than they could reach escape vehicles. The machinery keeping astronauts alive operates on thermal principles that require poison flowing through veins of their only shelter in the void. Finally, the Kessler syndrome collision risk. Orbital debris travelling at average velocities of 10 km per second transforms every paint fleck and bolt fragment into kinetic impactor, capable of catastrophic damage to spacecraft and suited astronauts. The debris population exceeds 100 million objects larger than 1 millimeter. Approximately 34,000 tracked objects over 10 centimeters create continuous collision hazard. Each impact generates additional fragments in cascading multiplication effect predicted by Kessler syndrome theory, where debris density reaches critical threshold triggering exponential growth in collision events. ISS regularly performs debris avoidance maneuvers when tracked objects approach within kilometers of the station's orbital path. Collisions occur at velocities where aluminum behaves like fluid under hypervelocity impact physics. Gram-mass projectiles penetrate multiple spacecraft walls. Astronauts during spacewalks become potential targets in shooting gallery, where projectiles remain invisible until impact and arrive too fast for human reaction time to register. The debris field represents permanent archaeological layer of human spaceflight, orbiting at velocities that transform every discarded component into eternal threat. Humanity's expansion into space creates weapon system pointed at future exploration, where the garbage of past missions becomes minefield that makes leaving Earth progressively more dangerous with each satellite launched and